All right, welcome. My name is Marc BOVET. I'm the official mascot of Bone Structure. Translation, the crazy Canuck that started Bone Structure 13 years ago so that we could suffice to situations like this and help people build or rebuild energy efficiency, very comfortable, healthy homes. I have with me a very impressive team that made this project happen in a very efficient way. And I don't know if I should always start with the architects or the builders, or I don't know. Well, because he's asking for it, I'll start with the architects. Brandy Kelly from K&M Architects, and your lovely wife is around here, no? Isn't she?
She's if a 10-year-old and a 13-year-old roll through here in a minute, then
okay, we'll introduce her then, because we know she's the talent behind you. All right, and we also have Mike, and you got to tell your last name on your own.
I do, huh? It's Dethlefsen, Danish.
Okay, so anybody wants to try that, you get to win 5 points. So Mike has a company called Mikara, and has basically put this up here. And we also have the one and only Todd Lubash from Wilkinson, and which also has contributed to this great operation. So without any further ado, the topic here today is building with the WUI zone, which stands for, and we had a debate about this 66 seconds ago, which stands for Wildland-Urban Interface, which makes sense. How is it that you deal with the beautiful surroundings that Mother Nature has offered us and preserve it? It's also called by other people Wildfire-Urban Interface, probably because of the result of what happened. And you had another name for it too, right?
no, but your son called it Wildlife-Urban Interface.
Oh, he called it Wildlife-Urban Interface. So
It's running around now.
So yeah, there's a bit of that. So anyway, the wild part is pretty much covered, and now we're going to talk about how we can make this urban interface in a much more responsible way, and how do we design homes, and how do we meet code, and how do we make our lives much more interesting in living in a sustainable, energy efficient home. So my first question for you gentlemen, and you're not allowed to hit the buzzer because we don't have a buzzer, is what are the basics of the Wildland-Urban Interface code requirements? Is there any volunteer to take this first question, which I'll repeat?
Brendan.
What are the basics of the code requirements?
Here are the basics, and I'm happy to answer first. The basics for, number one, it is a code requirement. CAL FIRE has a lot of opinions about it, and the CAL FIRE inspectors, so there's a lot of confusion about really who inspects or who keeps it. The biggest pieces of the code are the defensible spaces around a building. This is, I'll just state this very clearly. There's no such thing as a fireproof building. The point of the Wildland Urban Interface, the WUI zone, is to give everybody enough chances to get out, versus Australia, where there is a stay and there's a stay and defend idea, and California's code is moving slowly to a stay and defend mentality, because there's more and more houses being built further and further into the WUI zones, and we can't just tell everybody to leave, because many of them, Malibu is a good example, many of the houses that survived because people stayed and sprayed and defended their property versus leaving in the middle of the piece. So one of the code requirements is keeping everything within, I think, 100 feet or to your property lines down to 4 inches on the ground. Limbs up to 6 feet, so there's no low-lying limbs off of trees where a quick burning fire can catch a tree on fire. And overhanging limbs over a house are absolutely forbidden anymore in Sonoma County. And of course, the ignition barriers on the outside of the building and the roof, what we call Class A assemblies, both on the walls and the roofs, are all part of what I would call a long equation, not impossible equation, but it starts at the property line and goes right to the tempered glass that is on your window. Many of the fires that have happened off the park, the fires melted the glass, the vinyl surrounds, and went right through the house and burned them from the inside out. So the glass is a big part of the WUI code. Lane Backman here from Anderson Windows. A lot of people want to put glass in, for example, and he'll be the first person to say all this glass has to be tempered, and that, you know, it's a little more expensive. So anyway, that's the basics. Was that clear? Okay. Now we go to the second question. There'll be time for this. What does defensible space mean, and how do design and site planning play a role? I think that's sort of a continuity to this particular answer here. This house is on a very different location than the original house. All of the trees burned except for that redwood, which is actually the smallest of the redwoods that were here. And there's an oak tree. I think there were 50 houses here, or sorry, 50 trees. But the trees were a lot of, if you went to Paradise, the fuel that's sitting over the houses. So just, if they're removing the trees from, a lot of these houses today are just going to look bare compared to where it was in Fountain Grove and other places. That's the number one piece. And those trees, most of those trees burnt down in the fire.
So are you saying basically that into a rebuild, redesign, or if you were going to build in an area where there's almost a forest, you would have to trim down some of those surrounding trees in your design? Is that what you're basically saying?
Yeah, we're already seeing that in plans too for tree removal and what needs to happen before the building pad even gets set. So defensible space is a big deal there, for sure.
And what are the setbacks on that defensible space? Are there some very specific setbacks in terms of distance? Or?
No trees overhanging, and Cal Fire, I mean, Mike, you've had, I don't know how many houses sort of come near completion here. What happens on final inspection with the fire department?
Yeah, you know, in a city-based environment, like down in Coffee Park, you know, there was just nothing left. And so there's really no issues there. Where this really becomes an issue is obviously in an environment like this. We have a non-fire related project that we're doing out on East Santa Rosa off of Los Alamos Road, and putting in a single-story home, you know, in a heavily forested area, and to basically get the pad cleared to the point where the space was defensible, we ended up having to take down about 110 trees. Okay, and you know, some of them were in poorer shape than others, but you know, it was no small task to, you know, whereas before, you know, you would build, you know, almost around the trees, you know, tree coming up right through a deck, you know, tree overhanging the house, that's done. So, you know, in that particular case, it was a pretty massive effort, and we're still trying to get it stops. So it's not, you know, it creates the defensible space, but there's certainly an undeveloped property like that.
Okay, the third question for 5 points. You're ahead of the game now. We're the one always doing the talking, so I'm going to come up with questions for these guys. Specifically, how is required compliance reflected in new home designs in Sonoma County?
You know, I have some theoretical answers, but Mike's the guy who's dealing with inspectors right now on houses that are nearing completion, and I'm curious to sort of know what they're looking at.
I mean, the obvious ones, they're going to check for, watermarks on the windows, so that make sure that the glass is tempered. They're going to be interested to make sure that if you are in a wildland-urban interface zone, that you do have a Class A assembly, walls, exterior walls, and roof. They're going to make sure that the venting is done according to the standards. There's no open eave vents. If the eaves are less than 12 feet off of the current grade in that area, you basically have to have Vulcan vents or no vents, which makes...
What are Vulcan vents?
Vulcan vents are essentially, it looks like a normal vent, except that it's got this honeycomb look, and when it's exposed to high temperatures, the material expands, and basically that's a classic way where you get a fire rolling up underneath an eave, and you've got an open, like a typical three round holes in an eave vent, and it just blows right into the attic and lights the attic on fire from the inside, which then lights the house on fire. So
which is what happened here.
Which is effectively what happened.
Our house was still here at 6 o'clock in the morning when after that fire, based on videos from a neighbor. And by the time I got in here at 2, there was nothing left, and there wasn't even smoke.
And the fireball had went through.
Yeah, oh yeah, the fire.
It's just that the embers went into the attic, was sucked in, and basically that's what's... So the house could have been saved,
yes,
per se.
Had we known, and had we had any water, but the water system was a redwood fire barrel, so the water tank.
So this is Howard Booster back here, the owner of one of the owners of this property.
Or put it another way, if you would have had a bone structure home. I'm just saying. With no attics, that might have prevented the fire altogether.
So the bottom line is the windows, the exterior doors, the siding, the roofing, and basically the venting. Those are the big things they're looking for, and the same is true with the underfloor venting as well.
And the tempered glass requirement is only for the wildland interface
correct.
area?
That is correct.
I see.
Is Coffee Park in the Wildland-Urban interface?
It is not.
So none of these things apply to Coffee Park?
That is correct.
The city's okay.
I mean, obviously, you have to comply with all the current building codes, but from the standpoint of wildland-urban interface, it is still not designated a WUI zone.
I just want to call one of the reasons that BONE was so attractive as Howard and Merritt and Ray were looking at different technologies to think about this building construction. This building doesn't have any attic vents. It is an unvented attic. It has no crawl spaces. It's a slab on grade, and it sits on the top of a hill, smack in the middle of a is it high or very high? Do you remember, Howard? The WUI zone?
I don't remember.
Anyway, it sits on a hilltop that has a lot of wind, and of course, in a wildfire environment, wind and the top of hilltops are super exposed. It's one of the reasons that we looked at ways to not have a roof shape that was like a wing. We wanted all of what happened in many cases during the wildfire zone is that the embers would come from the fires well in advance of the actual wildfire itself, and it created, there's obviously a high pressure on one side, and just like a wing, it created a low pressure on the other side, and the embers sucked, literally, just what Mike was describing, right into the attics. I was in Paradise maybe 48 hours after the last of the wildfires were put out, and there would be a house, old house, with the 3 round vents, pine needles in the gutter, standing right next to a house that was right down. Nobody knows how wildfires really perform and the thermodynamics of these 2,000, 3,000 degree fires. The ways to defend is to eliminate vents in the crawl space, eliminate pieces, but the code hasn't required their elimination yet because there's so many other things about building performance. So that's one of the issues that contractors like Todd and Mike are facing.
Aren't those vents there for a purpose, and what do you do to accomplish that purpose without vents?
Really since World War II, high performance attics required to be vented. It was the way that you could make a good energy efficient envelope. Those two forces are opposing each other in a wildfire zone. As soon as you have a cathedral ceiling and you can shut off the vents, a lot of the vapor and moisture problems are not now in a ventilated space, easy to see, easy to inspect, and easy to sort of deal with. Now you're having things in sandwiches, and whether you're in Montreal or in Sonoma County, everything is now in a much, much more condensed space. It leads to some higher performance pieces, but from our standpoint, I think that the code is generally going to move to either unvented spaces. I mean, for a long time, you couldn't have unvented attics. You had to, and now the building code allows for it because there was so much proof during after the fires that so many houses didn't catch fire because a wildfire went through because they go through so fast. It's the embers and all the holes that are built for energy performance that allowed embers to come in, just like in this house, and they burn from the inside. I don't know if that...
You touched on it earlier, though, the insulation assembly is going out to the roof line, right? So instead of having the insulation box, if you will, at your ceiling, then you don't need that vented attic anymore, right? So as that assembly goes out to the roof line, you can deal with... Everybody's getting better at designing roof lines and roof assemblies and all the class requirements to be as fire rated as possible. So that technology is rapidly expanding, and we're getting better at that, and then that envelope goes out to the roof line.
And here again, just a lot has to do with the way we've been building and which material we've been using to build. As you've been building with wood, you needed that air ventilation in your attic because moisture would build up, and that wood would basically take on that moisture and you inherit mold situations. So if you use the right material to do the right job, you're basically preventing these type of situations. This is where a system like BOVET Structure has completely redefined, rethought the whole issue altogether. How do you get rid of mold? How do you get rid of drainage issues on flat roofs? How do you get rid of termites? Well, let's look at the basic of why is it we've been building with wood in the first place. Well, just as you mentioned after the war, but if you go back 375 years ago, we came off boats from Ireland, England, or France, and there was plenty of that natural resources. That was pretty much the end of research and development. Now, so our cars can self-drive themselves, our iPhone can send a SpaceX rocket to the moon, but we're still building the same old way just because we've always done it this way. And we've been suffering and maintaining these homes and surviving from these type of wildfires just because we have not rethought the whole process. So North America is probably one of the places still building with wood or have just built with wood. And this is, I think it is time for us to look at different opportunities in different ways. So BOVET Structure is one of them. There's other ways to build homes to make it more energy efficient and much more safe also in terms of whether it's wildfires or whatever Mother Nature is going to throw at us, because we sure know she's going through a teenager type of mood right now. She's unpredictable. And at the same time, the other issue is that and that's where the builders come in. We're in this day of age where there's a shortage of labor. So it used to be that you would hire carpenters, they've been brought onto a job, they've been with you for 10 years, they knew the trade, they knew how to calculate. Nowadays our kids prefer to go and design software videos or go into artificial intelligence, and we can't blame them. So who is going to assemble these homes, and how can we mitigate the risk of building these homes? As architects do very nice designs, they think out about the WUI and the zones and how to basically integrate Mother Nature into our lifestyles. But then again, who's going to assemble it, and how can you guarantee that what's been designed is going to be put up? So this is where we try to facilitate things, and I sure would like to hear a little bit about Todd's experience of assembling some of these bone structure homes compared to what you've been doing for the past, what is it, you're 67 now or something like that?
Yes.
Yes, he looks young, but trust me, he's got a lot of experience. So tell us a little bit about what makes this system differentiate itself and how it basically makes it maybe more user-friendly.
Well, it definitely helps to have the skilled foreman on the site, right? So they need to have everything on the line and understand how to do that work. So that's helpful. But it's those people have been with us for a long time throughout the years and have all those carpenter trade skills. When it comes to the assembly of a bone structure, the nice thing is that I can take guys that maybe have some labor skills and are looking to expand their worth within the company and take on the next step, but haven't really had any training in wood structure building, can be here on a site like this and be very effective in assembling this house. The other thing is they're not going to make a mistake assembling the house. They're not going to put the wall up wrong, they're not going to cut the wood wrong, we're not going to have waste because of that. It's less dangerous for them, as well as our superintendent to be watching out what they're doing. So in that regard, it's huge. It saves labor and time, and there's no reworking of the materials. And if I could do that on every job, I'm sure Mike would agree, if we didn't have any rework, any errors, any mistakes, any reordering of lumber, or guys going like this, then we'd be in great shape.
For which you always blame the architect, eh?
Yes, it's always their fault, absolutely. I still blame to go around even who can, you can always draw what you can't build.
Yes.
So as a builder, do you find it easier to bid on a project, or are you still doing time and materials when you've got such a large portion of the project outside your control?
It's a good question. We get this question all the time, but the project has a life of its own. The structure itself is part of the equation. You're going to make a lot of decisions outside of the structure and the foundation that will be dictated by your design and your architectural and engineering team. But you have selections to make on the interior, the type of cabinets you're using, the type of flooring you're using. All those things can add an immense expense, one way or the other, in your budget. So how do we bid it? We bid it off of a complete set of plans like we do any other house. And the more complete they are, the better the budgets are.
If I may add to that, what's a little bit unique about the bone structure system is that everything is digitally designed. It's like if we're building airplanes. So every part is conceived, and the cost of basically cutting these materials is very, very precise. We can tell you exactly how many parts went into this home. We can tell you how many screws went to this home, because every hole is already pre-pierced. There's no interpretation of someone on a job site about, oh, putting more screws here or more nails here or anything of that. The whole system is designed like a Mikara or Lego toy set. There's no ifs and buts. There's no interpretation. The different parts clip very precisely where they should go. So if part number 1, 2, and 3 did not clip together, you cannot go to 4, 5, 6, no matter which language you speak, no matter if you're measuring through imperial or metric systems. So the whole system was designed so that we could enable people in 25 countries, no matter the language, here again, no matter if they have tools or not. This is pretty much put up with very, very, very little tools. Most of it is battery pack drills. So when it comes down to the costing of this, well, because everything is digitally designed, we basically take out every part from that digital design and we add up, and we have to cut, make, and trim through these manufacturing plants. So that's very precise. As compared to some traditional methods, well, you get a bundle of lumber here, and then you select through that bundle which parts or which pieces of wood are appropriate to build, and people will cut these parts, and there's going to be a lot of waste, and there's going to be a lot of running around, and that's because we've always done it this way. So to answer your question a little bit more precisely, a structure like this or a home like this could be 25% of your whole budget. So how do you validate the next 75%? Well, that's where you go into a spouse meeting every other minute about how to indulge ourselves with either a $500 bathtub or a $5,000 bathtub. And that's where people like to get into a frenzy, because they've seen something last weekend which was a ceramic at $5, and then the sister-in-law comes in the next weekend with a ceramic at $25 a square foot. It's just that you forgot that you've got 3,000 square foot. So that's where a team, basically a team of people, bone structure being one of them, architects like Brendan, Mike, Todd, as we assemble a team with the clients per se, we are able to mitigate that risk from the get-go. It's not rocket science. It's all about planification. The more planification is done, the better the outcome is without any surprises. Now, at the same time, the bone structure will give you some benefits of very little or if no interior load-bearing walls. So you can change your mind basically as you go, or as you live through your house, you can basically make some modifications, you can add some windows, you can add some doors. So for once, the building will adapt to you. It's weird how the humankind has been adapting. I mean, the motto in real estate has always been location, location, location. And here again, we start with our first house, then we move to another house, then we move to another house, then our kids get off, so we move to a condo, then we realize that we're not made for a condo, so we move into another house. And every time we're doing that, we're derooting ourselves from our friends, our neighbors, some of them we're happy to deroot from, but anyway, and from our little habits. But why is it that homes do not adapt to us? They should adapt to us. The proof here, Howard and basically they've basically designed this house with Brendan so that the youngest gentleman of the house at 97 can have his home studio. So the house will adapt to the different lifestyle as it goes, and it will be here for the next generations 100 years from now. That is what's sustainable. That is what, it's unbelievable to see that the humankind is building houses. We're very active in different markets. Toronto is being one of them. We just demolished a house that was built 15 years ago. 15 years ago, it was mold infected, unsecured structure. It was built 15 years ago. This is, I mean, your jacket is going to outlast your home. It's totally unacceptable. So I think it's about time that humankind brings people, the smarts of people, with the shortage of the labor in this industry, that we come up with ways of making our lives easier, starting with the builders, starting with the architects, and even more so for the homeowners down the road, so that we can have homes that are very, very easy to maintain, are healthy, secure, and can give us a better life, as we can have a symbiosis with Mother Nature. You've got a beautiful place like this. The last thing you want is not being to be able to take advantage of it by bringing natural light and get us all off those Prozac and antidepressants at the same time. So there's a cost benefit to that. You can get off your antidepressants.
Well, can I just make, that's a great point, because as long as you can make the house last, that's in your green equation, and being green, you can't beat that. That's the biggest factor in that whole thing, right? If it's going 15 years, there's no green there at all. I don't care what you did to use sustainable materials or recycled materials, because it's all going back in the system. So that really is a great point. As long as you can make it last is probably your biggest factor in your green equation. This
is BONE's first wildland-urban interface construction, I believe.
Nope. The very first one at Jacobson was.
Oh, is it because it's next to the Stanford Hills, right? So, what we were facing, especially right after the fires, was not just the BONE technology, but a lot of Mike's experiences as he was starting fire rebuilds. And I just want to spend a minute on how BONE and Class A assemblies, and everybody know what a Class A assembly is? No. It's okay. So a Class A material is like something that doesn't burn, or it's not combustible, like a fiber cement panel or a steel roof or a brick. Those are Class A materials. But you can put materials together and they actually don't really mean anything to the fire code or the building code. It's actually how the materials are put together. So that's a Class A assembly. The insulation in a BONE system, just like the insulation in your house at home, is flammable. And all of the things that keep us warm are usually flammable because they are made of different materials. They're brick, and concrete and steel are non-flammable, but they are not very good insulating properties, right? So you're combining these two things into a complicated wall system, and then you're adding the Wildland-Urban interface rules to make sure that thermal barriers and ignition barriers are built into it. Mike and I were here on a week ago, less than a week ago, a few days ago, Monday, trying to finally figure out the detail to make sure that the vents on the bottom of the bone walls were going to be. Now the walls are vented. We talked about the ceiling not being vented, but the walls in all of the bone systems are actually just rain screens, and making sure that the bottoms are actually vented for any kind of ember or bug or mice or spider surfaces. The wall surfaces that you're seeing in yellow are the thermal and moisture barrier. Very unusual, but it needs now protection from the sun and weather. So we're building this cedar cladding. It's a Class A assembly also that protects the insulation, and it also needs to be protected on the bottom so that as moisture, fog, and wind and rain get into it, that it can also breathe on the back side. And Mike and his crew have been instrumental trying to figure out how to sort of do those pieces. Yeah.
So, Brad, I'm a little confused because you started out by saying the Class A material is non-combustible, but we're using cedar, which is combustible. So if you use cedar and plywood and fir strips together and they're thick enough, even though they're combustible, CAL FIRE has deemed cedar, if it's thick enough, to be a Class A assembly. Even though you can combust it, it actually takes quite a lot of energy, a lot of thermal energy to actually ignite it.
And how thick is that?
It's about 1.25 inches.
Yeah, it's about 1.25 inches.
We have a thicker piece, like window trim is going to be 1.5 inches, and on top of 1/2 inch plywood.
Any 2x material is considered Class A, not in the sense that it can't, it certainly can be ignited.
Right.
But what they're really trying to do is to increase the burn through time.
Right.
Okay.
So that would be a 1 hour wall, 1.25 inches.
They're rated in 1 hour and 2 hour assemblies, and the requirements are varied.
I see.
Yeah, a 1 hour wall is really important, and it's a different thing related to different, like when they're next to, like building structures that are next to each other. Because these buildings aren't close to each other, we don't need technical 1 hour walls, but they are effectively 1 hour walls.
Are we doing any sprinklers in these overhangs?
Sorry, what was the question?
Are the sprinklers being enclosed in these overhangs
No.
to saturate the walls?
No.
Yeah, you can't put sprinklers outside, except if you're in the city of Napa that likes them under awnings all of a sudden. But
You can't by code, or?
what happens is that they don't like them freezing in the winter time, and sprinklers outside and the temperatures outside don't align all the time, and you can really mess up a sprinkler system on a cold night when the sprinklers are essentially frozen shut and the sprinklers don't work. So, but let's get to I think your question is there a deluge system to fight a wildfire piece? And Howard and Mike and I have talked about sort of different ways to not only have a swamp cooler effect and misters, but during a wildfire event, one of the advantages of that tower is the ability to get up above the roof very quickly and have a hose and a pump and the ability to fill in the single gutter in the trough with water and dam it so that for a 24, 48-hour period, embers that are falling down into a place could actually be extinguished in one place instead of, 500 feet of linear gutters.
I think the big thing with Class A assemblies is to slow. It's not that a building like this building can catch on fire, right? Especially in an event like we had a year and a half ago.
Yep.
But the idea is that it takes more energy and more time to penetrate the exterior part of the building so that you can actually defend it, right? I mean, that's the whole point, is to try to stay and defend it, so that you have the ability, not to have Well, and Howard, you watched it. You watched that house right across the way that's not even being rebuilt yet. It's there, it's there, it's there, and then the whole thing ignites simultaneously. And that's because the building was being heated. And then when it finally did have an ignition source, everything had been preheated on the outside and the inside, and it was like watching a match head go up. It wasn't an explosion. It wasn't, you know, the propane system like that. It just
60
ignited.
seconds.
And then
60 seconds to lose a 3,000 square foot house from being there to not being there.
okay. So the idea is to slow it down so that you can defend it.
And to not allow any ignition into the envelope, and that's the Class A assembly. This is the roof on this house will be steel, and that's a Class A material. But under that is actually a very thin fiberglass layer, and then there is there's the insulation, and then there's another the peel and stick that goes on top of for the true waterproofing.
The member.
Yeah.
Well, folks, that's pretty much the end of the WUI panel. Let's give a round of applause to our I invite you to walk around and meet our staff. They're there to answer any question of any form. And let's remember, there's no crazy questions. There's only crazy people that don't ask questions. So go out there and enjoy the work that's been done here so far. Thank you so much.